Good morning and let me say good afternoon. We passed by 7. Okay, so I think we talk about 10.4. We are here. So you have algebraic of matrix. Okay. What do you mean by algebraic? Generally, when you say algebraic, yes. Yalla. Algebraic means addition, subtraction, right? So algebraic works like any operation that we have. So now today we have matrix, and we are going to work on the matrix. Maybe later you have a model in your life. You are making a lot of parameters, and you have a lot of variables. Then you are going to make it the matrix. The matrix will help you to control your parameters, a lot of parameters, to control them easily, to solve them easily. It's not like, for example, you have 10 parameters, you have a heat, cold, and I don't know, whatever you have in your field. Then you try to change to something else because you cannot solve 10 equation with 10 variables, right? You cannot solve. 3 by 3 is okay, 2 by 2 is okay. Two variables like x, y, we have two equations, it's called system, it's okay. But if you have 10 by 10, it's not okay. It's not easy to solve or count by, by hands. So in that case, we need to change to the matrix. Then when we change, it's easy to understand. So now we are going to take a fundamental things here, fundamental simple things here. One day, when you have a work in your MSc or anything that you want, you can understand what's going on with the computer. For example, you give your data to somebody, and the other will give you the result. You know what did he do, or what did they do. So here we are. We have an equal matrix. Two matrices called equal if all elements are equal. What do you mean by that? For example, if I have matrix A equal to 1, 2, 3, 4, and if I have B, matrix B is equal to 1, 2, 3, 4. My question is, these two matrices are equal or not? Not. Why? Because each location also should be equal. So in that case, if I have C equal to 1, 3, 2, 4, I say A equal to C, but A is not equal to B. Why? Because you can see this location is 2, that location is 3, so we cannot say they are equal. When I say equal, the location and the numbers should be the same. Understood here? So that's the definition of equal matrix. How about the second one, the difference and scalar multiplication, whatever you like? We have this one. So now let me give you the definition of the sum and difference and scalar product. For adding or subtracting two matrices, you have one condition, dears. Okay, one condition. What's the condition? The conditions say that A and M should be equal to B, or let me say, and we have B with NM, then we can say A minus B or A plus B. What do you mean by that? We mean by that if the matrices are not equal, we cannot add them, or equal, or in what? Equal in dimension, in the row and column. Look at here. You say Aij, Bij be M by N matrix. So in that case, we cannot, look, I mean by that, dimension N by M should, they should be equal. Means that if in the first matrix I have 2 by 2, the second matrix should be 2 by 2. Otherwise, I cannot add or subtract. To understand, let me give you an example. That's a rule. So I'm going to show you by example. Look at here. Oh, sorry. Good. Now, if x equal to, a equal to 2, 3, 0, 5, 2, 1, and b equal to 2, 5, 0 minus 1, and c equal to 0, 3, 5, minus 1, minus 2, 0. My question is what? Can I do A plus B? Dears? Do we have any chance to add them? No. Why? Yeah, here is what? A is what? A is 2 by 3. How about here? 2 by 2. So they are not equal. They are not equal. That's why we cannot add or subtract. Do you have any problem with that definition, dears? Good. Sorry. Let me use my program actually. Do some change. Yes. Okay. So how about A plus C? Can I have A plus C? For example, if A equal to 2, 3, 5, 0, minus 1, 2, and B equal to, or C equal to 2, minus 1, 0, and 5, 2, 1. So can I say A plus C? Of course. Yalla. A plus C is equal to what now? After checking the dimension is equal to 3, 2, 3. So you say yes, I can say A plus C. Okay. Of course you have a right to do it. So what's the number is equal to what? Easy, the same, yeah. Is equal to 2 plus 0. So each location with a location. You say what? You say, yes, 2 with 0. So I'll get 2 plus 0. 3 with minus 1. So 3 minus 1. 5 with 2. So I will get 7. 0, 5, 5. 2 minus 1. I will get 1. 3. Understood, dears? It's easy, just each location by location. How about if I have A equal to another matrix, A equal to 1, 2, minus 1, 0, and B equal to 1, 5, minus 1, 0. So tell me about A minus B quickly. 0, minus 3, 0 again, minus 1. Am I right? Why? Because we have minus. So minus means that multiply minus to here and add with there. So you get 0, you get minus 3, you will get 0 again, and you will get minus 1. Now it's clear? Do you have any question about the step? Understood? Yes, understood? Good. Now, next what we have? You can see also we have scalar multiplication. What do you mean by scalar multiplication? We have a number, we multiply them. How? For example, I have in this example, in the previous one, I say 2 multiply A. So it means that each element should be multiplied by what? By 2. So I'll get 2, 4, minus 2, 0. Clear? Clear, dears? Good, very good. Now, we are going to talk about more things here. Here you are, you can see. Kindly check that on at home. Why, for example, C plus A is not defined because the dimensions are not equal. Is undefined because of what? Because the dimensions are not equal. Good. You got that idea. Thank you. Now we have addition and subtraction and things between them. So we have a property. For example, if I have A plus B is equal to B plus A, generally. Okay, put your mobile away, thank you. Okay, so can we do it? Yes. This is called commutative. So it means that if I have two matrices, A and B, if I add them, it's the same thing with A and B. Careful. For addition between two matrices or subtraction will change, careful. Here we are talking about B minus, say careful. So here's the addition and things that we have. Good. Do you have any question about this property? Just look at it. It's called commutative, associative. What's the associative? Means that if there's a difference between the we have a parenthesis, you can play with the parenthesis here. You can manipulate with that too, or you can manipulate with that too. And what do you mean by CD? Means that if you have two numbers multiply. So instead of talking about the theorem, I'm going to solve that one for you. We have what? We have A equal to 2x minus A equal to B, where's A that one and B that one. Yalla, together. So, let me write the question. Solve that one. You see, solve that one. So I have 2x minus A equal to B, where A is what? 2, 3 minus 5, 1, and B equal to 4 minus 1, 1 and 3. Okay, now, before I'm starting, how we solve, for example, how we solve 2x minus 1 equal to 0? You know, we put the x in one side and the variables or the constants to the other side, right? So here we are. I'm going to change it like that. I say 2x equal to b plus a. Am I right? Or a plus b? Clear. And x is equal to what? 1 over 2 b plus a. Clear. So now I'm going to say x, which is a matrix, of course, the result will be matrix, is equal to what? 1 over 2. Where is a, where is b? Here we are. I'm going to add these together. So 2 plus 4 and 2, you're right, 4. Am I right? And of course, x will be what? These all multiplied by what? By 1 over 2. Each element will take the number. So we say x is equal to 3, 1. You are right. That's a solution. So this is called matrix equation. Matrix equation. Because we have an equation, x, we have an equality, so equation, but the elements are what? Are matrices. Clear? Do you think if I change the number, you'll face difficulty? No, just number changed. Good, well done. So, now we have multiplication of matrices. What do you mean? We have two matrices, we are going to multiply them. Before you are doing like that, you should follow some instructions. You have A, and you try to multiply by B. Of course, you will get the result C, right? If we multiply two things, the output, it will be some numbers. To multiply them, here's the dimension shouldn't be equal, but they should be close to each other or relate to each other. What do you mean? Here we have n by m, means that n row, m columns. Okay, now here should be m by something, say k. Okay, so what's the necessary here? The necessary, if you multiply two matrices, the column of the first should be equal to the row of the second. Look at here, understood? These two numbers is the key. We don't care about n, we don't care about k for multiplication. Clear? And the result will be n by k. The result will be the farthest one. So the nearest, the closest one, then we will get the farthest one. What do you mean by that? Let me give you the example. If a is equal to 2, 4, 5, 0. If I want to multiply by b, which is equal to 2, 1, 0 minus 1, 0. So tell me, can I multiply a by b? That's the question. Can I do it? I don't know. Let me check it actually. The first one is 2 by 2. How about the second one? 2 by 3. So because 2 equal to 2, of course, I can do it. And the result will be what? 2 by 3, you are right. Understood, dears? Okay. How about b by a? Can I do it? No. Why? Let me check. 2 by 3, 2 by 2. These two are not equal. You got it, I think, right? So if the clauses are equal, yes. Otherwise, you can't. Maybe at the same example, you can. If you change it, you can't. So in the multiplication, we don't have a sweep commutative. We cannot commutative them. But in the addition, if you remember, we write down like that. You see, for addition, it's okay. You can say a plus b equal to b plus a. Am I right? But if I change to the other operation, like a multiply b, I say they are not equal to each other. Even the dimension are equal, the result sometimes is not equal. So careful. And for example, if that one 2 by 2 and that one 2 by 2, 2 by 2, 2 by 2, we can multiply here, but the result is not equal. The result of the first is not equal to the second. So the results are not equal. That's why. So generally speaking, we cannot say is equal. They are not equal, generally, okay? In one case, they are equal. Later, we will get it. Do you have any question, dears? Clear everything? Good. So if I give you two, now, we got how can we do it or not? Now, how we do it? That's a question. How we do it is like that. Look at your lecture note. Look at here. I told you this is important. And how we multiply, that's the rule. We have a rule for multiplication. Look at this one, how we multiply. Row by column. Understood? Just to get the idea. Then I'm give you another example. For example, a equal to 2, 1, minus 1, 2, multiply 2, 1, 5, 2, 0, 1. So how we multiply that one? We say row by column and save it in row. So this is A, this is B, A2 by 2, B2 by 3. So we can multiply and I'll get C, which is 2 by 3. So how's the result? Just be patient and look at the first step. You will get the rest. Okay, dear? Okay? So, Kakajan, look at here. So we are going to multiply first row by first column, like L. I don't know, so like a 6 Kurdish 6, right? Rakam shash. How? We say 2. Let me change the numbers to recognize it, to be easier, familiar for you at home, at least. So I'm going to change each number by the other things, okay? To be familiar with you. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's be like that to get the idea. So I'm going to multiply first row by first column. How? I say 1 by 5. After that one, plus 2 by 8. That one will give you the first location. And you know, here we have 2 by 3. Am I right? So I have 2 row and 3 column. So when I multiply first row by first column, I will get the first location. So how about the second? The same. I'm going to multiply again by here, as I told you, like number 6. So 1 by 6 plus 2 by 9. Then what else? What else, dear?
1 by 7.
Yeah. Now 1 by 7, you are right. Plus 2 by 10, am I right? Now the first row finished. When you multiply the first row by the second matrix column, you will get the first row. When you are going to multiply second row, let me use that color. to the columns, of course, you will get the second row. So 3 by 5 plus 4 by 8. 3 by 6, 4 by 9. Am I right? 3 by 7, 4 by 10. Clear? Then you will get the result, of course. Understood? Did you get the idea? Hello? Good. Of course, B multiply A, we cannot. Good. So solve this one for me kindly at now. Can you do it? You have 3 minutes to do it. Yalla. IB. Look at here again. Look. So I'm going to follow the instruction here. So we have here, we are going to multiply by first column, right? So 1 by 3 by 1 by minus 1 plus 3 by 0, right? So I'll get minus 1. Good. Then we will do every single step together. So again, we have here multiply there. So I'll get 1 by 5 plus 3 by 4 was equal to 17 and go on. Tamam? There's the result. If you did a mistake, compare with your result, you will see where's the mistake. If you didn't understand where's the mistake, bring it back to me. Understood? Clear, dears? It wasn't hard, just do it. Good. So now, Taman, of course, at home try 25. Now we have a properties. Look, look. We have a properties, but you can see we don't have a commutative. We don't have a symmetry properties because we know multiplication is not symmetry. Here you can say distribute from left or right side. Now, he said that the matrix multiplication is not compute. Can you, let me check that off with you. So we have 5, right? 5. What do you mean by they are not commutate? You say they are not commutate. What do you mean by that? Means that if you A multiply by B, you will get the result. But if you can multiply B by A, you will get another result. How? You can see from here the result of AB equal to 68, 3 minus 3 minus 6, minus 1, 7, 48, 63. What do you mean by that? We say generally AB not equal to BA. So where's the example to show you? Sometimes you cannot multiply, change the multiplication because the dimensions are not allowed you, right? And sometimes even you have a chance to multiply, like here, we have 2 by 2, 2 by 2. So I can say AB also. I can count BA. Am I right? In both cases, you have a priority to do it. But here the result is something, and here the result is something else. Understood? So here we are. We got 2 different results. Look at here and here. So that's why generally are not speak. So maybe during the exam, I say find AB and BA, like example 27. Understood, dear? Anything to be worried about it? Nothing? Good. Did I upload the chapter 2 for you?